In this lab, our task was to calculate where a metal ball would land when rolled off of the table at a constant horizontal velocity. We used trials of independent aspects, including how long it takes to fall off the table and how fast the horizontal velocity would be, to configure the distance it would land and place a target accordingly so that the ball would land in the center.
First, we measured the height from the top of the lab table to the floor with a meter stick. Next, we put the ball on the side of the table and let it fall to hit the floor. We figured out our time by looking at the time the ball was no longer supported by the table and the time it hit the floor. By subtracting the time it took for the ball to hit the floor and the time it rolled off the table, we got our time for that trial. We conducted 4 trials in total and eliminated the trial that was the farthest from our prediction.
For the horizontal motion, we picked a set spot on the ramp and were careful to keep the ramp steady the entire time, as if it were to move, the data would be wrong. We let the steel ball roll from the ramp and started measuring its time after the initial bounce to about 10 centimeters before the end of the table. We did this 4 times by subtracting the time from the first bounce to 10 centimeters. We kept the trials that matched the closest to each other and found the average time. By dividing the distance the ball traveled on the table by the average time, we were able to find the horizontal velocity, which stays constant throughout the whole system.
In order to calculate where the target needed to be placed, we took our calculated horizontal speed and multiplied it by the time it took to fall off of the table. We got approximately 0.83 meters and placed the target accordingly.